Can you hear me?
Hello.
Yep. All right. Thank you for joining us. I know it's the last session of the day, so thank you for hanging on. It's going to be an awesome talk. Let me introduce myself. My name is Anil Dewan. I'm a product manager on the Google Cloud Launcher. And this is?
And I'm Bill Leaikas. I'm a software engineer from Seattle working on Deployment Manager and a couple of other cloud config things.
So what we're going to talk about today is this concept of no more dead software deployments. You know, I think we all know that deploying software is already hard enough. Anyone disagree? Okay. No? Oh, got one. A couple dissenters. We should talk. Deploying software is already hard enough, but it turns out when you move into cloud, deploying your infrastructure can often be harder. And so what we're going to do today is talk about some of the philosophies that have emerged over time, especially when it comes to cloud, to make this easier. And we're going to show you some of the tools we've built on the Google Cloud Platform that you can use to implement those philosophies to make sure that you're no longer deploying dead software. And then finally, we're going to show you some of the improvements we've done to the Google Cloud Launcher product that integrate and tie it all together. Okay. So for the first time in cloud, you have this unprecedented ability to spin up a whole host of resources, from virtual machines to firewalls to disks in one zone across multiple zones around the world. And that's fantastic. And what happens is when you get these powerful tools that let you spin up these resources in a matter of minutes, is you tend to use it a lot, right? You no longer are constrained or confined to plugging in Ethernet cables and managing your own data center. So you're now trying different things. You might be experimenting with a staging cluster in one environment. You might be ramping up a production cluster in a different zone. And that's exciting. It leads to complex architectures, but also gives you some great benefits, like agility. You can finally take an idea, put it into practice, see if it works. And if it doesn't, tear it down. Not a lot of cost to it. So the flexibility you get is fantastic. But as Spider-Man was told, with all that power comes a great sense of responsibility. So great, you spun up all of these resources, and you've SSH into those machines, and you've tuned that kernel parameter to make sure the IOPS are going to be great. But now when you want to move to a larger system or scale down or replicate that setup, what do? And so the default state is what we call dead software. And dead software comes about because you've lost control of what you did. You created these unique snowflakes, and they were great when they were there, but you no longer know how to get back to it. And what this means is if you're not going to have a way to get back into that configuration repeatedly, you're going to be vulnerable because your software is going to go out of date, and you're going to get things like configuration drift because what you had in your mind is not what's running in production. Well, as you can imagine, some people have tried to solve these problems, and there are tools that do so. But they're not a whole lot better in terms of solving a problem. And I think what they lead to is potentially something worse than dead software, and that is zombie software. What these tools try to do is they try to patch a running environment to try to keep it up to date. In concept, that's great. But we all know the reality is when you're patching a running system, you're never going to be able to make it work 100% of the time. Well, when it fails, it's really difficult to roll back. I mean, it's equivalent to trying to change the tires on a car while it's running. It's something you probably wouldn't want to do. So great. So we've seen this. We've seen this kind of model happen in the on-prem world. And when you move it to cloud, this problem becomes exacerbated. So there's got to be a better solution, right? Well, it turns out there is. And it's actually quite fascinating. In the last few years, this pattern has emerged around immutable infrastructure. And if you saw the Spinnaker talk today, you know exactly what I'm talking about. And the goal of immutable infrastructure is to say, hey, let's no longer change the tires while the car is running. Let's instead take all the components that comprise your application, bundle them up into one immutable image. And you can do this through the notion of a bakery. And this whole process is co-developed in the industry. Externally, we've seen folks like Spinnaker by Netflix, but also internally at Google, we've been doing these patterns ourselves for several years with Borg config, and Midas. So this is great. Once you have an immutable software package, you have an atomic unit that you know is good and you can trust it. But that's only part of the battle. You've got this atomic unit, but now you want to make sure that you can repeatably deploy it in a multitude of environments, right? There aren't many tools that can do that really well. And that's what we're going to talk to you about today, which is how do you implement immutable infrastructure on Google Cloud Platform. We're going to show you our tool of implementing this philosophy. It's called Deployment Manager, and we're going to walk through a set of examples of how to get a quick VM up and running, and then showing you some more complexity and building it up over time. So what we want with configuration and management of infrastructure is a few things, and kind of a very high level. One is you want repeatable deployments. You want to know that the code you're running is going to match the infrastructure you have in mind. Next is you want to be able to take that same code and reproduce it in different environments as you scale. And finally, but perhaps most importantly, you want a single tool and model to describe and deploy these things. You don't want to have to change what you do because you're now deploying Google infrastructure versus your own resources or a third party's resources. And this is really where Deployment Manager comes in. Okay, so what is Deployment Manager? Deployment Manager is our tool in Google Cloud Platform to create repeatable, idempotent deployments. Okay? It's got a simple YAML-based, so human-readable description language with Jinja and Python code behind, so it's extremely flexible. And it, as I said before, it can configure any GCP resource type. So you're no longer constrained to just VMs. We can do Kubernetes, App Engine, IP addresses, firewalls, the whole range. And we've got a great G-Cloud command line built in. What Deployment Manager gives you is resource configuration that you can treat like source code. You can version control it, you can share it, you can understand the evolution over time. And it uses these declarative templates described in YAML. And what those give you are these repeatable infrastructure deployments that you use on that G-Cloud command line. All of these things put together with these templates and the command line integration allows you to think at a much higher level of abstraction. And in fact, as we'll show you today, you can start describing parts of your architecture as components and start using those and consuming those components with higher level building blocks. All of this put together gives you what we call living software deployments. And so I'm going to turn over to Vile, who's going to show us Deployment Manager in action. Let me switch over to the demo.
Thanks, Anil. Okay, very good. So I'm going to go ahead and talk a little bit about very basic things from the beginning. We all face with very simple things like how do I get my code up and running in the cloud? So there's a couple of ways that you can do this today. As Anil mentioned, you can go ahead and go out there in the bakery and you can say, hey, give me an image. Whether it's a Docker image or whether it's a VM image doesn't really matter. For this example, I'm going to be using VM images just to keep things simple. But once you have that nicely baked image, you want to go and get it up and running in the cloud. And we certainly have solutions for you to do this today. You can go up there on the cloud console and you can go ahead and turn some knobs and slide some sliders and out pops a VM for you. And that's all great. But then if you want to go and redo that, say a week, 2, 5 weeks later, you come back and you're like, what was it that I do? I can't remember. You can also do this from the G-Cloud compute tool. You can go in there and say, hey, I would like to go and spin me up a VM, give it some command line flags, and out pops a VM. But you're kind of faced with the same problem again. The only thing that you do have now is maybe a command line history, so you can hopefully spin back up to it. But we can probably do a little bit better on that. So I'm going to go and show you how we can do this with the Deployment Manager today. So for the Deployment Manager, you go ahead and create a configuration file. It's a YAML-based file. It looks like this. It's very simple. At the top, you say, I would like to create some resources. Well, that's nice. Then you say what you would like to create in a form of a list. So in this case, I want to create just a single VM called my VM. I give it a type because we need to know what type you're creating. This one is a VM, but as Anil mentioned, it could be just as well a network, load balancer, firewall, whatever it is. And then you give it the list of properties. So the properties should look familiar to you if you have used compute in the past. There's nothing new here. They all look and feel the same because they are the same. Because the API is mapped one-to-one between the underlying resource and what the Deployment Manager talks about. Okay? So I give it a zone, a machine type, in this case F1 micro because it's a demo. I give it a disk. I want to boot off of a persistent disk using a source image that I have baked already for this demo. It's creatively called Node.js static because I'm not very good with naming. And then I have network interface. I would like to say, please give me a network interface that I can actually access from the internet. I say, give me a NATed interface, one-to-one. That means that it's going to give me an external IP address. Okay? So using a gcloud command line tool, I can say, Mr. DM Manager, please give me a deployment. And I give it a pointer to my YAML file. Oh, I also have to give it a name, so let's call it my VM. Okay, so while that's going on, the nice thing is that because we were able to go ahead and, or once we created a YAML file where we put all these properties into it, I can now go ahead and take that file and I can put it into source control. I can put it in my GitHub. I can keep track of what changes on that file and when does it change, who made that change, and why was it made. That's a really powerful concept. And for this simple case, it doesn't really matter that much, but you could also do things like unit tests, right? I could come in there and make sure that I know that I have a step in there that actually says, I'm about to deploy something. How do I know that I'm actually deploying something that makes sense, okay? And also remember that all the properties that I created or defined in that file were mapping one-to-one to my underlying APIs. So I can go ahead and use this tool today without having to understand any new technologies or any new languages. I can just go and take the properties that I know and love from the Google Cloud and just go and create my list of resources and say, please give me some stuff in the cloud, okay? So let's look at this happy little VM we just created. Let's do this first. I'm just using gcloud compute tool if you've used this from the command line, and I'm asking it to describe what my VM looks like. Zone. Okay. So there's a couple of things that we really only care about in this one. There's a lot of stuff here, but it was nice that it actually got the machine type right for me. So I wanted an F1 micro, so it created me that. That's nice. And it also gave me an external IP address that I can then go and say, curl against it, and it prints, surprisingly, hello world, right? So at this point, we can now go ahead and take this file, and we can go and put it in as part of any kind of pipeline that I have, and I can go and tear this thing up and down all day long. I can come back to 2 weeks later. I can give it to Anil, and I can say, hey, Anil, would you like a VM?
I would love a VM. But, okay, Vili, that's great, but we're Google. Like, if I wanted to change something, let's say I wanted a larger instance, or maybe I want to change a zone, are you telling them that the best practice is to copy the file and make the changes and check it into source code and now have 2 copies? That doesn't sound the right thing.
Yeah, I mean, you don't have to copy it. You can cut and paste.
Fair enough. I mean,
okay, fair enough.
More old school than me.
Okay,
That's cool.
yeah. So so we can certainly go and do that. And we have built in some templating capabilities in the deployment manager. And I'm going to go and show you a little bit how that would go. So let's go and say that we want to go ahead and run 2 stacks. Say we have a dev stack and a prod stack, and I want to have a VM running in both of those. And again, I want to keep these examples very, very simple, just so we can all follow along and not get cluttered by all kinds of different config, but in real world things will be more complex, okay? So we can come in to my handy dandy Emacs. And again, if we look at this file, I templatize it, okay? And the way we do templates is either by using Jinja or using Python. For these examples, I'm using Jinja, but we have plenty of examples showing Python as well if that is what you want to do. Notice that the file looks very, very similar to what we had before, right? So at the top, we have resources because I would like to create resources. I have a list of them, right? In this case, I only have, again, 1. And for the name, I have just parameterized this. I can now say, OK, when you go and use this template, you need to specify a name. And I will use that name to name my VM. I'm still using the same type for my compute v1 instance. And then I have, again, the list of properties. Zone doesn't change because you didn't ask for that. But here is where we introduce a little bit of magic here, where we can come in and saying, okay, I would like to go ahead and add a new property and a little bit of programmability, so that I can come in and saying, okay, if you'd like to create the prod environment, we'll give you a super beefy N1 standard too. Not really, but you know, it's better than an F1 micro for this case. Otherwise, just create me an F1 micro, okay? And then the other parameter that I added is because we probably want to go and run 2 versions of the different code. I probably want to go and continuously deploy to my dev stack, so I'm going to go and parameterize my source image so that it's going to go ahead and boot that VM off of that source image instead of always hard coding, because you probably don't want to run the same version of the code in the same environment. And everything else is the same, okay? And then to use this, I am going to go ahead and again create a config file that looks pretty much the same that it did before, with a couple of exceptions. One of them is it has a section at the top called imports. So think about that like your import statement, where you say, I would like to use a different kind of a type. Okay? And I give it the name. It's my VM template Jinja. And then I give it a list of resources. Okay? So in this case, the resources, again, it looks and feels the same. It's got a name, type, and properties. But for my type, now I'm using this new type that I have just created. Okay? So the type is the template that I just created, a new type, user-defined type, with only 3 properties. Okay? So I can go and say, okay, the name, right? If you remember, that was the name that is given the underlying VM. And an environment. That was an optional field, but in this case, we specified because we want to go and run it. And then I'm going to go and give it a different source image. Okay? So to get this up and running, I'm just going to go ahead and point to my second file that I just created, the single VM2, and I'm going to give it a different deployment name because I want to create a prod environment. Okay? Now, while that's going, let's go back and look a little bit about the my template here. And the one thing you might point out is, okay, well, this is really nice, but it's going to be very tricky to go and remember how do I use this template and what are the properties that I have. And while you could certainly go in and use your grep powers and everything else to find out the things you care about, we have introduced a concept of schema, not Scratch. There we go. Where we have a JSON schema that you can attach to each one of these templates and types, right? That describes what it is that this type does. So I can look at it and say, info, okay, it's a single VM template, great. It's written by me, and there's a description that you can use, and then a version, right? So you can keep track of versioning that you can add in addition to your source control. And then you have a section that says, here are the required parameters that you must give when you want to construct one of these types, okay? So in this case, I only require for you to go and give me name and a source image, so I know what to boot, right? And if you remember, there was an if-else clause, so I didn't make the environment required, so it's not as part of the required list. But all the available properties are then listed in a section called properties, and each one of the properties is described by what the name of the property is, in this case name, a source image, and an environment, as well as the type, because this could be an int or whatever else it is, and it also has a description. So you can easily inspect this file and look at it and say, what does this thing do? What can you do for me? Okay? Oh, yay, it finished. Okay, so now we have a prod front end, right? So let's go and look at that a little bit. And again, I'm just going to go and describe that VM. Maybe. US. Yeah, I'm a great typer. Okay, so the machine came up, which is nice. And then if we look at it, we can see now that the machine image has been changed to our BFE production instance. Okay, that's nice. And again, if I just look at this the external NAT that was given it, I can go ahead and ping that and see that it's my production environment, right? So at this point, I have been able to go ahead and take this thing, again, put it in the GitHub, and I can go ahead and, in case like this, now you can start to see where you're like, okay, actually this one I might want to go and write some unit tests against it. So if I go and specify a property as a prod environment, I actually want to go and see this kind of a machine spinning up.
That's cool. I mean, that's pretty cool. But you know, I know you're a copy and paste guy, but like a lot of people in the audience, I use microservices. So 1 VM, 2 VMs is kind of cute, but talk to me about microservices.
Microservices. This guy's never happy. Okay, so that's great. So DM really lends itself, deployment manager really lends itself very well to microservices, right? Because if you start thinking about now the abstractions you can create, right? One of the example that I created before was very, very simple, right? It's a simple VM, and that's nice. But if you think about it, that it can create any kind of a resource for you underneath it. It could be a highly scaled, load balanced service endpoint for you that you connect to. So to go and demonstrate that concept, I'm going to go ahead and use again my trusty old VM template Jinja, and I'm going to go ahead and run MongoDB on that. Okay. So again, the first resource in my list doesn't change. It's, well, except with the name, but I'm again using my type here that I created before. I'm going to call it MongoDB, and I boot it off of my MongoDB image. Okay. However, if you notice, I am adding a secondary resource that I'm creating as part of this type that I'm running. Okay. I am creating a service registry endpoint here that actually allows me to go and solve the second problem that I have when I run microservices, right? So the first part is I'm going to nicely define them and saying this is my microservice. And then I'm going to be able to go ahead and decouple that from the consumers of that particular service. So in this case, what I'm doing is I am actually producing a service endpoint that my customers or consumers of this service can use. Okay? So again, it is just another GCP resource. So I just specify a type differently from a VM because I'm not creating a VM. And I give it some properties. And the properties in this case, I am just giving it the address of the MongoDB above. But if you notice, I'm using a syntax with the $ref sign here, and that is actually allows me to go ahead and start creating orchestration. So deployment manager is going to look at this list of resources and it can say, I can create a MongoDB because it doesn't really depend on anything, but when it gets down to the MongoDB endpoint, it's going to say, oh, I need to go ahead and wait before creating this service registry endpoint because it depends on MongoDB. So DM is going to go and spin up the VM, and then it's going to go back into that network interface of that MongoDB and pull that out and then stuff it in the service registry. Okay? And it also, so this, because this is a GCP resource, it actually means that it behaves like a first-class citizen. You can list your services. You can say, hey, what are my services? I might have dev services. I might have prod services, staging services, and so forth. I can create them and delete them and everything else. But the other nice thing that it does behind the scenes for you is that it also creates a DNS entry for you in your GCP DNS. Okay, sorry, GCE DNS. Okay. So that means that without you having to run your own naming and discovery services, this endpoint will be visible through you in the DNS, and you can just use this from your VMs and Kubernetes clusters and all of everything. And you can also restrict the visibility of this endpoint so that it's maybe only visible to your dev network or test network or whatnot. So let's go ahead and spin that up. Okay, so while that's going on and it's creating that, so let's go and just step back again and think about the value that we are able to do now, because we are able to now be able to decouple the production and consumption of these services by using the service registry. That's a really powerful concept in itself. The second powerful concept that we have here is by building these abstractions, I can go ahead and very easily and with a very high degree of confidence be able to come in and saying, like, when I need to bring up my dev stack, no matter how complex it is, because I have treated it as source code, right? It's checked in somewhere, it's got tests associated with it. Every time I just go and spin up these stacks, I know that they're going to come up, okay? It also allows me to go and nicely document these things with the JSON schema. We saw those things, right? So it was very clear and easy to go and see how it's used and so forth. So there it is. It now comes back and says, thank you. I created you 2 resources like you asked me to. So it created a MongoDB, and it also created a MongoDB endpoint for me. Okay. So let's go and see what this looks like. So in this case, I'm just going to go and SSH into the machine that I created in the first case, my little single VM. My VM. And I'll just grab this name endpoint here. So if you look at this name that we created here, the nice thing about this name is that it is carved out into its own namespace so that I can easily go and say it was the MongoDB endpoint, it's scoped to a project, and it's also separate from your other DNS entries so that there's no kind of collisions between what other people develop or add in there or anything else. So if we just grab this from here and I'm running in that VM that I created that had no knowledge of my handy dandy MongoDB even existing, I can now come in and I can see it from my single VM, creating a nice decoupling between my services. Okay. Can we go back to slides? Okay. So let's go all the way back and think about what we just started. So we started with a very simple declarative YAML format, right? It was really nice and easy. We could just go ahead and come in and look at all the properties that we already know. If I know VMs, I can go and come in and create my VMs using concepts I already know, okay? And the second thing we added on top of that was, okay, that's great, but how do I parameterize that? How do I create my own types? How do I add programming in there, right? So we saw a little bit of that using Jinja templates. Again, we also support Python, but these examples are using Jinja, okay? And we created new types. So this is really powerful concept because now what I can do is instead of thinking about my cloud resources as just resources, I can start composing the resources that I want to and put them into GitHub and describe and declare what it is that they actually do, how do they look like, I can test them, and I can really start treating all of my configuration as code. It should be treated just like code. You'll be happier. And then I also showed you guys how we can go ahead and start creating microservices built on top of those abstractions by using the service registry as a loose coupling mechanism between the producers of the service and the consumers of the service. Okay. And so at this point you might say, okay, that was great. You showed me a couple of VMs and everything else, but you know, in reality things are really, really complex, right? And I agree with you. They definitely are very, very complex. So if you think about, this is a pretty standard kind of a pattern that we see all the time, which is I might have highly available, auto-scaled, load-balanced thingamajigger running, right? Let's call it my front end, right? How would I go and do something like this in the cloud, right? It's pretty complex, right? Well, the nice thing is that by us showing you how you can go ahead and create and reuse some of these types, we've also created a bunch of these best patterns and best practices that you should be able to use right out of the gate. And we have many of these examples in our GitHub that we'll show you in just a second. And the second thing is that, again, in the production, you probably don't want to go ahead and, even though you can reliably go ahead and deploy your production architecture up and down at will, you probably don't want to go and tear down your entire infrastructure because your customers might not be happy during that. So we have a couple of things that allow us to go ahead and update parts of our infrastructure like a rolling updater. And can I get back to my machine just for a moment, please? So, oh, that's big. Okay. So what I have done here is deployed ahead of time exactly the picture that I just showed you, okay? So I have a next demo. And then what I have is I have created a new high-level type called HA service, right? And you can see it right there on the top. It says, oh, you have a HA service. That's great. And your HA service is composed of three things. It's got a service stamped out into two zones, but it's just two instances of the same type, okay? And then on the bottom, we have an LB load balancer, okay? So now when you look at the picture that we just showed you, and we look at the actual resources that were created, you can do one-to-one mapping and saying like, oh yeah, that's what I deployed. That's nice. And then if you drill down to each one of these things, like let's say our L3 load balancer, you can start to see that at this level, I have a new type where I have taken three primitive GCP resources. I have wrapped them into one LB3 load balancer, and I have that hierarchy information right here. So I can come in and I can see the application, how it's built. And then if I look at my service, I can see that I have this updater that I called you before, that I mentioned before. It allows you to go and take a managed instance group and give it a couple of images, and it'll handle the rolling update for you. So in this case, we have updated from Ubuntu into CentOS. And it also has it has an instance group, and it has an autoscaler, and so forth, right? So this is this HA service type is very powerful because it basically takes in maybe about 5 or 6 properties. It takes some auto-scaling parameters, give me the lower bound, give me the upper bound, give me the pointer to your code, and give me the zones you want to run in, okay? And it just spins it up for you. Then you can come back to it later and you can say, oh, I would like to update my running code. You can just give it a new image and the rolling updater will update that for you for the zone that however you want to go and configure it. Typically, you probably do one zone at a time, but however you want to do that. So let's go back to the slides. So we have quite a few people that have been using Deployment Manager for a while, and some of them really like it a lot. So it's not just me. So here are some of our customer quotes that have been using and building things with the Deployment Manager for quite a while. And we are very happy that they are happy, because that's nice to hear.
So Deployment Manager is great, and Vili described to you how you can use it for your own infrastructure. But when it comes to building solutions in the real world, you're often just not using your own software, you're often using software from other sources. So how many of you use third-party software today in your own environments? Pretty much everyone, exactly. And this is where Google Cloud Launcher comes in. Just a quick show of hands, how many of you have used Launcher already? Okay, so quite a few. For those of you that haven't, just a quick overview of what Launcher is. Launcher is the marketplace inside Google Cloud Platform for you to get started running third-party software and services on GCP. It's integrated directly into the developer's console, and we'll show you that in just a moment. And it's not just about getting simple VMs up and running. We actually have very sophisticated solution configurations, which we'll show you. And what that allows you to do is not just kick the tires on software, but actually run it in production. And especially for large enterprises, one of the big benefits here is you get a single bill. So you're using third-party services and software, but it's all going on your single Google bill. So no more separate POs just because you want to run MongoDB. We've grown quite a bit. We have over 160 solutions from a variety of great commercial partners. You probably recognize most of the names on here today. And beyond solution growth, we've actually seen phenomenal customer adoption. Just over a year ago, between a year ago and now, we've kind of 4x'd or grown 400%, which is just outstanding. And the customer feedback has just been phenomenal. We've been hearing great feedback around people being able to deploy solutions a lot faster now that we have the ability to give them third-party software directly within the console. And so I'm going to go ahead and show you Cloud Launcher in action and demonstrate some of the integrations we've done with Deployment Manager. So we're in the demo machine. Okay. So I'm just going to switch in here. Okay, so here we are in our Google Cloud Platform Developers Console, and Cloud Launcher is now integrated directly into the menu. So you just click here, you can find Google Cloud Launcher right there. This takes you directly to our storefront, which allows you to browse all of the solutions we have. They're categorized. You can also search through them. And so I'm going to go ahead and find, let's say, a MongoDB. So I see one here. You can quickly learn about what it is, what it can do for you. We highlight the key aspects that you care about, like, for example, what version of Mongo is it running, and how much is it going to cost me in the specified configuration. And we actually expose the pricing in a very detailed fashion, so you actually know what you're paying for at the resource level, and we even show you your sustained usage discount, which I know you all love running on Google Cloud Platform. So that's great. So let's now take a look at what it looks like to deploy MongoDB solution on Google Cloud Platform in the launcher. So I just click launch, and what you see is not the same interface that you would get when you're trying to deploy a VM. What you get is instead something very tailored specifically to deploying Mongo. How many of you have deployed Mongo yourselves? Okay. How many of you enjoyed that process? Nobody, not a single hand, exactly. Totally relate to your experience. And this is really where I think the power of the launcher really shines. What we have here, we're going to show you, is how you can run production configurations just by a few clicks in a wizard. So what we've done here is we've exposed some of the key things you'd want to configure for Mongo, namely server nodes and arbiter nodes. So what you can do is you can choose your zone, that's great, and then you can choose how many nodes you need. And so let's say I want to stick with 2. And what we do is we have intelligent defaults. We've sort of, over our experiences, know what makes sense to run different types of software. So in this case, we're suggesting using a high mem 4 vCPU machine. You can change that if you don't like it, of course, but we're going to stick with that. And since we're running database software, you may want the extra performance you get from running an SSD. And last but not least, you probably want to control how much storage you have attached, so we allow you to control that as well. Well, in any MongoDB configuration, as you can see here, you have your primary and you have secondaries, and then you also have this arbiter. Well, you want your primaries and secondaries to be beefy, but the arbiter is not doing a whole lot of work. All it's doing is kind of being available for heartbeats and doing some leader election. And we've captured that concept in our configuration. So what does that mean for you? That means that you're not unnecessarily paying extra just because you need another machine. We've instead suggested using an F1 micro, the smallest instance size, to run that arbiter. I'll go ahead and click deploy, and what you're going to get taken to is the same experience that Vile just showed, namely deployment manager. And so as this week, we announced that all of the packaged software solutions available in Cloud Launcher are all built on deployment manager. And what that means is you get access to all the rich resources and templates that Vile just described, along with all of the power. So you can deploy once, bring it down, tweak some items, and now get repeatable deployments that you can integrate with the rest of your software solutions. So this might take a little bit to deploy, but I deployed one earlier while I was watching another one of the sessions. I called it here, GCP Next Mongo. And the things I want to highlight here are, we're not just giving you a deployment. We're not just bringing up your infrastructure. What we're actually giving you is a single pane of management for that infrastructure. So what do I mean by that? Well, if you're running MongoDB, you have these primaries and you have this arbiter. One of the first things you want to do after you deploy this software is start using it. And so what we've done is we've bubbled up the primary actions directly on this page. So for this MongoDB solution, I see that I can have a button that's SSHing to the primary and the server. And this is taking advantage of our Cloud SSH feature, which allows you to not have to worry about keys. There's not a single person who doesn't love this feature. I know all of you relate to it. So here we are. Now we're in our machine, and this is the primary. So out of those 3 instances, we've already shown you how to get exactly to where you want to be to begin with, the primary. And I'm going to show you it running in action. So I'm just going to go Mongo localhost. And since this is a replica set, there are going to be multiple nodes in the replica set. So let's go ahead and query the status of that. And as you can see here, the replica set is set up the way we want. We have namely a primary, we have a secondary, and then we have that arbiter. And what we've done behind the scenes, what I'm not showing you, is SSHing into every one of those VMs, piping IP addresses and configuration, making sure each node can talk to each other. And you've seen this deployed in just a matter of, well, seconds really. And just as proof of that, the deployment I kicked off is actually up and running, and we can do the same there. Let's go back to our slides here. So hopefully what we just saw was that Cloud Launcher is probably the easiest way to get started, especially running third-party software and services. Not just kick the tires, but you could actually run it in production. We've got a wide variety of software, so if you've used Launcher in the past, I encourage you to come back in. We're constantly adding new solutions. And since it's directly integrated in Developers Console, what's great for you as developers is you're no more than a few clicks away from deploying like amazing third-party packages whenever you need to, right? You don't have to go outside the console. You don't have to futz with anything outside of providers or billing. It's all integrated. And last but certainly not least is all of our package software solutions, as I mentioned, are now integrated directly with Deployment Manager. This gives you full transparency. If you messed up and didn't like some configuration we did for you, that's fine. Download the template, tweak it. If you want to compose with what we did, go for it. Yeah, it's all available for you. All right, so wrapping up this talk, a couple things I want you to take away. First, as we talked about earlier, is this notion of using immutable infrastructure with repeatable deployments is going to increase the chances that it's just going to work, right? You're going to go from having deployments that are snowflakes, things that you can tweak once, may never be able to replicate again, to something that you can stamp out repeatedly. Deployment Manager, as we've seen, is our Google Cloud Platform native tool for implementing that pattern. It can deploy resources and images, whether it's VM images or containers. And Cloud Launcher solutions are a great way to get started, but not just to kick the tires. You can use them in production and then start composing more sophisticated solutions because the solutions are now based on Deployment Manager. All of the demo code Ville showed you today is available at our GitHub repository, so I encourage you to check it out. And so putting this all together, hopefully you've seen how we've moved from a world of dead software deployments to living software deployments. Thank you.
Thank you.